Today I'm going to try and fix my DeWalt saw. The on-off switch has packed up. Now I've been on the internet and a new on-off switch for it is $80 plus shipping. So I'm going to explore other options. So I've got the old switch out. It's a Weber UNIMAT WTN22-555 and oh dear, lots of broken bits here. Yeah, this is like I think this is like beyond gluing or fixing. Oh gosh, it's all black inside as well. Okay, so this clearly is, I'm not going to be able to repair the old switch. So this is what the DeWalt switch looks like internally. So let's explain exactly what's going on here. So the live is a double pole switch. The live comes in here, goes out here. Neutral comes in here, goes out here. This is a double pole switch and it's connected together. Now when you press the on side of the switch, what happens is it pushes down both these contacts and they make a connection and obviously produce the voltage out here which makes the saw run. Now releasing the switch would just cause it to just immediately release because it's just sprung loaded. There's no latch or catch to hold it on. So what actually happens is that when we make this connection, we've got voltage coming out here. There's a coil, that big coil you see sticking out the back of the switch, energizes, and the solenoid, a small piece of steel, goes into this solenoid and is held in. So in other words, you push the switch on, makes the connection, energizes the coil energizes and it holds the switch in the on position. Now this type of switch is called an NVR switch. It stands for no volt release. So what happens is that if the mains goes off, a circuit breaker goes, or there's power cut, or it's just unplugged, whatever, you can see what happens is that this solenoid would release and the switch would automatically go into the off position. So if the current is then reinstated, the saw remains off. It doesn't come on by accident, which as you can imagine would be an extremely dangerous situation to happen. So that's why it's called a no volt release. In other words, when there's no volts, the switch releases and goes to off. Now the DeWalt saw switch has an extra little bit in that it's got a resistor here, a small coil, and this is a tiny weeny heating element that goes around a bimetallic strip, and the more current that flows, the more this gets heated up and the more this strip bends. Now this strip, if it bends too much, in other words if there's too much current flowing, what it does is it makes the switch go to off. It just pushes here, and obviously as soon as you push the off button it pulls this and it breaks the circuit, solenoid collapses and there's no power. So I've drawn this diagram with this bimetallic strip actually pushing the switch off. In reality it doesn't actually work like that. What happens is that this on arm here is it actually, as you comes down, it clicks into this solenoid part here, and that holds it on, and then the spring here, the plunge from this bimetallic strip, actually pushes on here, and it releases this piece of metal here, so that this breaks the solenoid pulling it down, and the spring then makes it go to the off. You can imagine if it didn't work quite like this, then you could actually just, once you've overloaded it, hold your finger on the on button and it would still work. And you'll notice on your saw, when it has overloaded, if you put your switch on by pushing it on, it just goes click, it goes, and then immediately keeps going off, because what's happening is you're pushing this piece of metal down here, it's clicking down, but as soon as you take your hand off it, it's going click, it's not staying on, it's going click, chunk, and it's flying straight back up again. So I've just taken this one out of stock. This is a standard YH-02A standard machinery switch that you get in everything. You'll get these in bench grinders, cement mixers, everything. And this is another one of these no volt disconnects type switches with an internal coil. There's a little diagram on here showing you the in and the out connections, and it's a double pole switch. So I'm going to try and put this one in my saw. Now I know, of course, that this hasn't got any overload protection. It's only a no volt release protection device. But I'm not too fussed about that with my DeWalt saw, actually, because I've got it on a motor overload circuit breaker anyway. That's a much better one than a built-in DeWalt one, because when it does trip I can reset it immediately, whereas the DeWalt ones are very frustrating. It can take an awful long time when you're using it to reset them again. So let's just see if this one fits. Well, it's close. It's not a million miles wrong. And I probably will fit it with a stop button next to the handle for safety. So now, how do we get this switch in here? Well, clearly I can't take anything off here, plus I don't really want to damage my saw. Now I can't really take anything off here because that's a nice shroud. But I suppose I've got plenty of plastic on this side here. So I could maybe file some off there and see if that would actually fit in the hole. Obviously I'm going to have to destroy a perfectly good switch here, but it's probably worth the risk. Moment of truth. I tell you what, it's not far wrong, is it? So what I need to do is, there's a small piece here on the DeWalt saw. It's very close. You can probably see there's a piece here that's just sticking out. I think what I'll do is I'll just remove a tiny bit of that piece sticking out the saw there. Right. Whoa, look at that. What a lovely fit. And it even, gosh, it even clicks into place. Well, I think I can safely say that that's a good success anyway. And that looks lovely. So the original DeWalt switch had 2 screw connections and then 2 spade connections. So I've soldered on 2 spade connectors onto the original. So if you're not familiar with the circuit diagram of the DeWalt saw, I'll quickly run through it. Basically, you've got an incoming mains cable with three wires in it, and you've got a wire that goes to the motor, slightly thicker wire that's got 4 wires in it. The green and yellow that goes from the input goes straight to the outlet through a tiny little terminal connector. So this is the green and the yellow. Green and the yellow run straight through. The brown and the blue go to the input side of the switch, to the 2 input connectors. Then on the output side of the switch, you've got a blue wire, so blue goes to blue, and this goes straight to the motor, this goes straight to the mains. And then on the other side, on the brown side, you've got a black wire. Now the black wire connects to one side of a capacitor, this is the start capacitor, and then it just simply carries on as a black wire into the motor. So in other words, that blue and black are your actual running wires, so it just goes black through to the motor, and then you've got an additional wire here which is your brown wire, and what the brown wire is the brown wire is the capacitor output. So So probably the easiest way to make the A1 connection is to just make up a tiny little link wire. There we go. That means we have to modify our circuit so that the complete circuit we finished up with is the A1 terminal, which is here. So this is A1, and then that had another little link wire we connected to that went to the black of the capacitor. So what happens now is the switch live comes out of number 4, goes through a black wire to the one capacitor, and then goes to the motor, and then also comes back and connects the A1 terminal, which actually holds it on. So what I'll do is I'll make the connections again. So where are we? We've got the so that means the neutral goes to this side. Oops, this way round. Just make super sure I've got it unplugged. Right, there's the live out from the switch, and then we want the little A1 wire which will go to there. Actually, whilst I'm at it, I think this base here isn't quite right either. There we go. It's a nice precision fit. Oh, there we go, that fits lovely now. Now where this live wire is going to go, the A1 wire, that's got to go onto the black wire that's this wire here on the capacitor. So in other words, all 3 black wires get connected together on the capacitor. So let's just tidy up all these wires nicely here. There we go. Now, take 2, moment of truth. I haven't plugged it in. Okay, moment of truth, take 3. Success at last. That's nice and solid, that switch. In fact, actually, this switch is this is a nicer switch than the original DeWalt switch, actually. So I think it's much safer as well, because your hand naturally slides onto the stop button. So if you think this video has been helpful, just press the like button, and if there's 20 people out there daft enough to watch any of my videos, then what I'll do is I'll publish some more